All right. Okay. Hi, everyone. So, what I'm gonna do now, unless there is kind of other questions, stuff like that, is I'm just going to go through problem 1 from lab 8, which if you're stuck on kind of the beginning of project 2 might help you. So, this is Gamoku. So I'm just gonna copy and paste that. So we have put sequence on board over here. Oh, hello. Okay, let me. Hi. Oh, there's no people. Okay. Uh, all right. So,
I'm sitting here because I'm charging.
oh, okay. Okay. Yeah, okay. Okay, so what I'm gonna do is like as promised, I'm gonna do problem 1, and then I'm gonna kind of answer whatever questions people have. Okay. So what you're given in the handout is put sequence on board, right? So that looks kind of like this. So here what you have is you have the starting coordinates, so just yx. And then the idea is you're just saying put COL, so color black or white, on board yx. And then update y and update x, right? Does that make sense to people? So to put it kind of in more concrete terms, so it might be that the y is 1 and the x is -1. And then let me just take this kind of thing, copy and paste it. Sorry, I'll be back on here in a second, right? So if I'm saying, dy is 1, dx is -1, and I'm saying something like x initially is, let's say, 0, and y initially is, x is 4, y is 0. Then what I'm doing is I'm saying put the sequence like this, and then add 1 to y, subtract 1 from x. So go here, and then go here, and so on. Right. So that's kind of the idea behind this. Is that making sense? And then here I'm just doing it like length times. So it might be that if COL is W, then putting it here and here and here. Right? So dy dx is kind of give me the direction. So it might be, that, so y goes from top to bottom, and then x goes left to right. So it might be that dy is 0 and dx is 1, and then I'm going like this. It might be that dy is 1 and dx is 0, and then I'm going like this. It might be that dy is 1 and dx is 1, so I'm going diagonally like this. And it might be that I'm going with the left diagonal like this. Right? So that's put sequence on board. So the question here is sequence complete? So this is basically saying, are there exactly this many stones of this color starting at y start x start? Right? So I'm going to say, like this. So just with this one, if I say is sequence complete, like this board, and then I say y is equal to 0 and x is equal to 4, and dy is 1 and dx is -1, and length is 3, and the color is W, then that should be true. But if I say, length of 2, then that is false. Right? Because like there is a sequence there of white stones, but it's not complete. Yeah. So, okay. So how do I do this? So essentially here, what I'm doing is I'm putting the stone of this color on the board. What I need to do in is sequence complete is essentially go through this sequence and just check that it's that color. And then I also need to check on either side whether there is a stone of the same color, essentially, on either before we started or after we started or after we ended, right? So just gonna copy and paste this. So this is, again, this is just the put sequence of the board from the handout. So here, instead of saying, is it make it equal, I'm saying, is it equal? So I'm saying if it's not equal, then I'm done. I just return false. And then if I haven't returned false, I just gonna keep updating the y and x coordinates, right? So now, and this would be helpful for is bounded, right? So what I need to check now is there a stone of color COL on either side of the sequence? Right? So how do I do that? So let me first not worry about the fact that they might go out of bounds. And instead, what I'll do is I'll just say, like, is there something here? Is there something here? So, okay. So how do I check? How do I get this coordinate? I actually am already there, right? So the last time that I updated y and x, I updated it to this guy. Because if I start here and I update 3 times, then I'm here. Right? So what I'll ask is just like if board at y at x is Now I worry whether it's equal to COL because that means that the sequence wasn't complete. Then I return false. So I also want to know what's over here. So in this case, the answer is nothing, but I want to go over here. So one way to do it is before I update y and x, I just go the other way. I subtract dy from y and I subtract dx from x. So that's kind of the easy way to do it. If I want to do it at the end, what I have now is y and x, and I kind of want to go back. So how do I go back? Well, I just say, so here I just added dy length times, right? So in order to go back, I just need to subtract dy length times to go back to the original, subtracted length plus 1 times in order to go back 1 square more, right? So I'll say if board y minus dy times length plus 1, same for x. Right, so this is kind of like the easy way. Here, what I did is like I just added dy length times. So if I want to do the original y minus dy, I need to do the new y minus dy times length plus 1. Is that okay? Not okay? Yeah. Yeah.
Okay, so I don't quite, I know it's a little bit earlier, but line 160 through line 162, why does it return false if the position previous is?
Well, so the goal here is like whether the sequence is complete. So if the sequence is not kind of the start of the sequence, the end of the sequence, then I don't want it. Yeah. Yeah. Does that make sense? And this is kind of the same kind of thing as is bounding. So what I haven't done yet is I haven't checked whether this is actually a valid coordinate or not, right? So, you know, the easiest thing to do is to just say, actually, I have a square on board here, or I don't. So I'll just make a function. And I'll just check, so like if y is not between 0 and n, return false. And if x is not between 0 and n, return false. Otherwise, return true. And kind of do it like logic it out like that. Or you can just say, make sense? So that's the same. So like the only way this would be true is if both y is between 0 and n, and like smaller than n here, and x as well. So here, before trying to access those coordinates, I'll just check whether it actually makes sense. So I'll just say if then it'll check. If not, then there's nothing to check because it's outside the board. And similarly, I'll do it here. And then this is just the other, so I don't want to write it out. So I'll just do this and this. Is that making sense? Is that okay? So if nobody says anything, I'm just moving on. Okay, nobody said anything. So 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 the way again, kind of assuming that you're kind of getting started, the way I would approach it is, so like is empty is easy or relatively easy. You just check every square on the board, right? So is bounded is kind of the same logic, right? So what is bounded is asking is actually assuming that the sequence is complete. You need to figure out whether it's open or semi-open or closed. And the logic is the same. What you need to do is you need to look on a kind of at x minus, so y and x and plus dy plus dx. And you also need to look at the other end, which is what I've written here, right? Over here, more like. So you just need to kind of like change the math here a little bit. Right? And then you just need to like check, like, so what's closed, just, like there is like either a wall or a stone of a different color on both ends. Semi-open, just one end, open, empty squares on either end. The coordinates of both ends you just figure out using this kind of math. Right? So detect row essentially, there's multiple ways to do it. But one way to think about it is to just say, I'm going to go through the row. So going through the row means like maybe I'm looking at this diagonal, right? And then I'm just going to start. So I know what color I'm looking for in that particular call, right? So it's saying like, I'm looking for sequences of 3 whites, or I'm looking for sequences of 2 black or whatever, right? So to go through the row, this is how you do it, right? So this is going kind of through the row. If the diagonal is shorter, you need to account for that, but that's basically going through the row. And then what you can do is you can say, okay, so if I'm looking for white, basically I need to find situations where there was a white just before and then there was something different. In that case, you know that you're at the end of the potential sequence. And then you just check. Make sense? So one way to think about it is, let's say that you have a list that's like ones and zeros. Right? And what I'm gonna do is, let's say that I'm looking for like sequences of 3 ones, right? So I'm gonna say, okay, so like for I range. And so I'm just going through those, and I'm saying, okay, so rank comes 0, and I'm saying if L at I is not equal to 1, that means that I'm potentially at the end of my current sequence of ones. Right, so I'll say if current count equal to 3, rents 3. So I'll show you how it goes in a second. And I'll say current count is equal to 0. So essentially, so what's going on here? So I'm saying current count is like how many ones have I seen so far before the current sequence of 1 has ended, right? So I'm saying, okay, so current count is 1, current count is 2, and now LTI is not equal to 1. So I'll check, is my current count 3? If it is, then I maybe found something. If not, then I just reset current count to 0, don't do anything. Current count is 0, doesn't change because it's not equal to 1. And then current count is 1, current count is 2, current count is 3. And now I'm here. So I'm gonna say, okay, is current count equals to 3? Yes, great. So that means that I'll print the location of this one, which is I minus 3. Right. So the only situation is that when I'm over here, that hasn't ended. So I need to like, again, check at the end, is current count equal to 3? Because it might be that I have a situation that's kind of like this. And I'll just print again, I minus 3. Right. Does that make sense? It's just like to account for this one, which doesn't change into a 0. Right. So that's kind of like going through a row, right? So the only thing that you need to do is so in addition to doing for I in range, rather than just look at L at I, you're looking at board YX, and you keep updating the Y's and the X's. Right? So that's one way to approach it. Another way to approach it, which you can also do, is you could just say, I'm going to try every possible starting point. And I'm just going to see, like, at this starting point, is there 3 whites? At this starting point, is there 3 whites? At this starting point, is there 3 whites, and so on. Makes sense. So you don't have to use is bounded, but you can. Yeah.
If you have a sequence say like 4 1, you want that to be counted.
Well, so like in this setting, no, because so like here, like the analogy is like detect row. I actually tell it I'm only looking for sequences of this length.
You're getting graded on each of the functions or like the
Yes.
final?
Each of the functions. Right. And then detect rows is just run detect row for every Y start X start around the board, right? So, you know, like every row that starts like here, or every like horizontal row that starts like this, every vertical row that starts like this. And then you have, you know, diagonals that go like this and diagonals that go like this. And you just, you know, call detect row repeatedly, right? And then search max is just so once detect rows works, the score function works, and search max is just trying every so similar to lab, I don't know, 6 or something. You just try every possible move, score it, undo it by just overwriting it with a white space again. And you know, keep the location of the minimum. That's kind of what I was planning to say.
You gave us like a score function, right?
Yes.
What does that have to do with search max?
So the job of search max is to find the coordinates, the coordinates on which if you move on those if you make a move on those coordinates, then the score is maximized.
It's a good question. I don't know if this is relevant, but how is the score function defined? Like, why is it defined the way it is?
Yeah, so I mean, like it's like not necessarily the best one, but it's something that kind of works. So you can go back to the lecture where this was introduced, I guess, as well, for like a longer introduction. But essentially the idea is so this is computing the best move for black. And this is saying that if black has moved and there is an open sequence of 4 white or a semi-open sequence of 4 white, then black has lost. So that makes the score very low. And then, like, if this is non-zero, this is non-zero, nothing else matters. But if those are 0, then the next most important thing is if there is an open sequence of black of length 4. And so. I will post those very soon. So yeah, so yeah. So for now, like I want people to kind of make their own test functions as well. But I will post the code for those. All right. So I guess kind of the way I want to do it maybe is if people feel like they have questions that would apply to other people as well, then this would be a good time to ask. And then if it's more like an individual question, if there are no questions that you feel are like helpful to everyone, then I'll just stop the stream and I'll answer individual questions.
Oh, one concern I have is like let's say you're doing like searching for length 2, right?
Mhm.
But what if there's like a length 3? Would it detect the length 3?
So
and-
that's not a complete sequence, so only complete sequences count. So if you think about this thing, so for example, this diagonal
Yeah.
only contains one semi-open sequence of length 3. It does not contain, sequence of length 2, according to the definition in handout.
But like you're looking at also like the sequences of length 2.
Yeah, I mean, I understand what you're saying, and what
Yeah.
I'm saying is those are not complete sequences, they do not count.
Okay.
Yeah.
So like you could have 4 diagonals and then your length is 2, how would that?
Zero, like in the same way that like for 3, like this is just 3, there is no sequences of 2 here,
Yeah. But
or like diagonal.
okay, so if it's connected, then it's
Right.
considered one sequence and it's over the.
I mean, that's one way of thinking about it. The way I would think about it is more like this is a subsequence, so like this and this, but it's not a complete sequence because there is another white stone here. So it just doesn't count according to the handout. As a sequence of length 3, 2, it's just a sequence of length 3.
Oh, maybe that's why it's.
Yeah.
Okay. The way I interpreted it was.
Right.
If you have
Right.
4, then you 2.
No, so like that, and like you could like also check just like the tests that were supplied with the handouts, like that kind of addresses this as well.
Oh.
Yeah. Okay. Is there any general? Let me check Discord maybe. Oh, it's open. Okay, there's nothing here. All right, so if there's no general questions, then I'll just stop the stream and we'll stay here. Oh, that's nice. Do I stop?